For the CS470 group project, Group 7 decided to create a inventory control system database. Group 7 consists of Emily, who was in charge of database DDL and backup testing log, Debsankar, who was in charge of ER diagram, schema diagram, requirements, feature scope, deficiencies, and me, who was in charge of database security. Now from here, Debsankar will go in depth on the actual design of the database.
In this project, we are solving an inventory control order fulfillment database design problem. So the situation in real world shows something like the picture in the middle, like a store where we have an employee that logs into the device and select a sled, and then each sled has assignments. The employee picks a product, then he or she places the products on the shelves, and then assignments are updated into the device by the employee. They record the time, start time and end time. So this real world problem is translated into the mini world, the database world uh, solution by a database design process which has three steps. Namely, first step is uh, gathering the requirements. Second step is doing the data model. Third step is creating the physical model. Our project has three layers: the database layer, the business layer, and the front end. So the entity relation and schema diagram are the beginning of the steps for the database design. So in the entity relation model, we basically define the entities and establish the relationship between them. In this project, we have defined device, employee, sled, product type, assignment, tote, these entities, and there are attributes that we have defined there. So this entity relationship diagram is then further normalized, applying first, second, and third normalization forms to create the schema diagram as shown in the right. The schema diagram represents a logical database diagram. So from the schema diagram, we can specify our schema and start creating our physical diagram.
The user interface or front-end design of our database will be a web application. We didn't actually create the web application, but this is an example of how it would look. We do have the beginnings of a Java-based interface on the AWS cloud, as well as a Python script to access the database. So those would be options as possible starting points for future development. So the employee would have a tablet that would attach to the sled that you saw in the introduction picture. And the first page the employee is going to see is the login page to input their employee ID number. And all of those employee IDs will have previously been inserted into the database by whoever has access to that specific table, probably the employee's manager or supervisor. And so that's the first SQL query that you see here, is inserting those employee IDs. And so before accessing the database itself, the application is always going to validate the values input by the employee according to the limits of the values. So in the case of the employee ID, we had it as a 10-digit integer, so it's not going to take any text input or a shorter or longer integer. An error will be displayed like the one that you see on the screen, and the employee will have to put in their input again. So once it's confirmed that that is a valid employee ID, then the application will access the database to confirm that it's found in the table and that it's not already been assigned to another device. And so that's the second and third SQL queries that you see, is confirming that. And once that's confirmed, upon hitting login, then the database will actually be updated. So that's the fourth and fifth queries, to update the database, to assign the device to the employee, and set the device as checked out. And then the app is going to move on to the next page, which is sled selection. And so the sled selection process is very similar to the login process in terms of validating the input, returning errors if necessary, and updating the database. Along with selecting Sled, the employee also has the option to log off the device instead. And so in that case, the application is going to perform the necessary deletions from the database so that the employee is no longer assigned to that device, and it will return the application to the login page. So once the sled has been selected, the app will move on to the assignment selection. The employee must select at least one assignment to be able to begin a pick, and they can have up to 6 assignments on a sled at a time, anywhere from 1 to 6. The app performs similar checks for validity as the employee is entering those assignment IDs. And then the pick direction selection that you see is utilized in displaying the picks, which we'll see on the next page. And the number of totes required is drawn from the database using the assignment IDs as their input, so the employee knows how many totes they will need to get before they begin picking. And once all the assignment IDs are validated and input, the database is updated as soon as begin pick is selected. So if instead the employee selects log off sled, there's no need to do anything with the assignments, so only the sled will need to be unassigned and the database updated for that purpose if log off sled is selected. So once begin pick is selected, the first page of the pick will be displayed. So the right hand picture here is what it's going to look like for the employee, displaying the products that they will pick. This example has 4 products on one page, and then the 6 small boxes are representing each assignment, and in other words, each tote that is on the sled. So it can be up to 6 or as few as 1. This particular example has 4 assignments, so 4 totes on the sled that are going to have products placed in them according to this pick sheet. And so the application creates the order pick pages using the assignment IDs that the users input, and then it draws from the database by creating a list of the product IDs for each product in each tote that is part of each assignment on the particular sled. And so you can see it pulls the location where those products are located. It pulls the number of products for each specific tote, and then it also gives a total number of that product. That's a summation from all of the totes, so they know how many of that product they're getting in total. And then it lists all the other necessary information, the store number, batch number, etc., that the employee will need for that tote. And then the green box shows that that particular tote has been completed once that product is placed in it. So the tote is closed, sent on the line, and a new tote is started, so you can see that the tote number has changed on the next product picked. And once all the products are picked on that page, the employee selects next page, or they can hit previous page to go back and see what they've already done. They hit next page, and the next 4 products will be displayed. And they're displayed in ascending or descending order as determined by the user selection on the assignment selection page. And so it's assumed that the assignments will have products in, or some of the same products. And so that would actually be ensured by making sure that the assignments selected are in the same zone. So that's not something we put into our database just for simplicity, but that would be something in the actual development to ensure that the products can be displayed sequentially. And so once the last pick is reached, instead of saying next page, the button will say like drop assignments. So upon dropping the assignments, the database will be updated to mark the assignments as completed. The web application will return to the assignment selection page, where the employee can either log off or they can select more assignments to continue picking.
So when it comes to securing a database, it's important to know your database, and that way you can fully understand where the vulnerable areas are in the system. Now, using this knowledge, we can decide which security measures to use based on the function of the database and who can access the database, etc. Now, as Debsankar and Emily said in previous slides, our database is an inventory control system where employees log into devices, and from this point, employees select sleds, and each sled is a given assignment where employees are to pack certain products into the sled based on the given assignment. So knowing the basic operation of this database, we can use certain security measures to prevent data breach and or leakage. So the security begins when each employee logs into a device with their employee ID. Each employee ID is a 7-digit numerical value. If the value entered in the login is not already saved in our database, the device will redirect the employee with an error message seen right here at the bottom of the screen. Our database also stops employees from logging into multiple devices at once. Once the database sees that they are already connected to a device, the database will display an error message stating that the employee is already associated with another device, also shown right here at the bottom of the screen. Now, a crucial part of the database is the employee IDs. Once entered in the device, the employee ID's data is encrypted, so that way if there's a data breach, the employee ID isn't displayed within our database. The encryption will camouflage the ID into random gibberish, shown right here. So it basically took the input, right? Let's say this is employee IDs. I say camouflage it. It camouflaged it into this. So basically it turned into a bunch of random letters, numbers, and symbols. So basically something of no value. Now, another way to stop unauthorized access to company databases is only to allow access to the database on a company server. This will limit hackers' ability to access the system anywhere other than on a local server. When it comes to internal company security, our database is a role-based access control system. This way, only certain trusted employees can access important information within the database. The system will know if the employee is trusted based on the ID entered into the device. Now, if the ID entered is one of the trusted employees, then they'll have more access to company information. We've also used connection strings. Now, this is important that we don't show our SQL connections within our source code. That way, if there was a data breach, no important credentials would be accessed within the system. So instead of showing SQL connections in the source code, they can be stored in a web config or an app config. And now in our system, they're stored in a web config. Now, throughout this project, one of the greatest lessons I learned was a lot of key issues within database systems can simply be solved by writing good code. It sounds oversimplified and silly, but there's a reason why people focus on quality code. If people follow basic requirements of good coding, they seem to fix most issues that attribute to most IT systems. Even though this seems very simple, I learned it firsthand how important it is when it comes to finishing this project.
Let's talk about the deficiencies and future scopes. We worked on this in this project as a learning organization. It means that we learned in the classroom and then implemented parts of the project. So those go in parallel. So this is a deficiency in our project that it would be the best scenario if we could start the project with all the best practices we learn uh, in a place, and that is as a starting point. And then in the entity relationship model perspective, it would be helpful if we could have a possible extension to purchasing and logistic units. In future, we would like to have some extension to department-wise inventory placement that will provide us scalability. Right now, we have just floor and the positions like the shelves, the rows, columns, etc., the base. And then we need to have a fully functional web-based UI in future. An API-based transaction management with integration to SSO would be a great thing for future. And from the security perspective, grouping the permissions and roles at the user level is very nice to have enhancement for the future.